Assalamu alaikum wa rahmatullahi wa barakatuh. Um, Hello, my name is Ifan Arif, and today, alhamdulillah, I am in college Madrasah as a student there. And today I'll be teaching you about chapter 1 in subtopic complex numbers. And I'm sorry, but I'll be teaching in English as a training for myself. And inshallah, I'll try to explain it slowly and carefully and showing you every concept for this question, right? So, given the complex number z and its conjugate z bar satisfy the equation z multiplied by z bar plus 2z is equal to 12 plus 6i. Alright. So, firstly, we understand that complex numbers are formed in this way, a plus bi. What you want to do with x plus yi is also a complex number. Any algebraic form, as long as there's an I to present as the imaginary part, while the a or x or anything in front that doesn't have the I value will be called as the real part. Okay, so let's say I want my z to become a plus bi. Z is equal to a plus bi. And we all know that the terms for conjugate is that the real part will keep the same value, while the imaginary part will change. Its direction will be negative. So if we write down z bar, the only similarities that we have for z bar and the normal z will be a, but the difference will be the direction for the imaginary part, so it will become minus bi or negative bi. So we will be stating that z bar is the conjugate for z. Okay, so that is how we find our conjugate. Now for the next one, it's our conjugate. Remember that is our conjugate. Hopefully you guys can understand this part. So the next part is we are going to substitute the values for z and z bar to the equation that has been given, which is z bar plus 2z is equal to 12 plus 6i. Right? So all we have to do is to execute the algebraic law or the rules of it, where we know that z and z bar are multiplied, so a plus bi multiplied by a minus bi. So this represents as z times z bar plus 2 multiplied by the complex number z, a plus bi is equal to 12 plus 6i. So right now we have already established an equation, and after we simplify the left hand side here, we will be comparing the real part and the imaginary part of the right side. Okay, that is our goal for now. Alright, hopefully I can get the right answer. Wait, let me check. Okay, so, oh, by the way, they ask for possible values, so this means that z will be receiving more than one, so make sure that you will get two kinds of complex number, because the question needs possible values, which means is more than one. Alright, so a plus bi multiplied by a minus bi. So in complex numbers, we learn that if the conjugate multiplied by its origin, which is, for example, x plus yi multiplied by its conjugate, which is x minus yi. Okay, so the long way is we multiply each term, and we will get x squared minus xy, imaginary number or I, plus xyi, and then minus or negative y square I square. So if you recall that we learned that for I is equal to the square root of negative 1. So what happens if we square I? We will get negative 1. Since the power of half, which is 1 over 2, we will be simplifying it if we square both sides. So that's how we get negative 1. Therefore, we know that the term negative xy and positive xy, we can simplify it because both of them have the similar terms, but unfortunately, they're negative, the values are pretty different, which is negative and positive. Therefore, the sum of both of these terms will be 0. And then remember, I squared will be negative 1. So therefore, x squared minus y squared, and we can just substitute the value for I squared, which is negative 1. And then finally, we will get x squared plus y squared. Okay? So if you apply this same concept to the question, then we don't need to do this long work. But if you're not used to it, then I recommend that you get used to the long method to get to x to the power 2 plus y to the power 2. Alright? Oops, sorry. So, okay, let's substitute. So, a plus bi bracket or multiplied by a minus pi, we will get a squared plus b squared. Okay, so that's basically the product of these two complex numbers, and then we expand the two value to the right side to get 2a plus 2bi is equal to 12 plus 6i. Now we can do one thing, which is we can compare. We can compare the like terms, which is the ones where it has the like terms such as I and the real part, or let's say the imaginary part and the real part. We compare those two terms. 2bi and 6i are both complex part, the imaginary part, while a squared plus b squared plus 2a and 12, both of them are the real part. So we compare these two. So we have created two different equations, which is a squared plus b squared plus 2a is equal to 12, while 2bi is equal to 6i. It's okay, we can bring the I, because no matter what, the value I will be simplified, since the left hand side, the right hand side has the same term, which is I and I. Both of them has the same value. So if we multiply both sides, or no, we divide both sides with I, we'll get 2b is equal to 6, and then we divide both sides with 2, you get b is equal to 3. Now you will be asking yourselves, why do we get the b value only a single value, but the question needs more than that? Well, if you notice that the a, or the value a, is squared, alright, so remember, for squared terms or squared values, that will be called quadratic equations. And we know that quadratic equations will be giving us two different values, or alike values, or whatever, but still, it gives us two values. But let's see, what kind of values does this question give us? So a squared plus 3 squared, remember we substitute b into the equation. So a squared plus 3 squared plus 2a is equal to 12. Now, we can solve this equation, because we are left with one term, which is a, or one unknown, which is a. So this creates an algebraic expression, or algebraic equation, yes. So all we have to do is to make sure that it is in the in quadratic form, which is ax squared plus bx plus c is equal to 0. Then we can solve it. So by oh my gosh, by taking out 12 both sides, we will get a squared plus 2a, and then we know that 3 squared is equal to 9, and then 9, I'm sorry, should have been negative 12 plus a squared. So 3 squared minus 12, we will get negative 3 equals to 0. Now we can solve this by factorizing the quadratic equation, and we will get a minus 1, a plus 3. Now there are kinds of methods to factorize quadratic equations. You can use your calculator, you can use your own method, but that's for another time. But for now, let's just use what kind of method that we are used to it. the ones that we are comfortable with, then you can use it. As long as it's the right way and you get the same answer. So we can solve this by separating the factors, which is a minus 1 is equal to 0 and a plus 3 is equal to 0. Now we can express a, so a equals to 1, a is equal to negative 3. Right now, we know that our complex number should be z is equal to a plus bi, and now we have our values for a and b. And for the final answer, remember, we have more than one, so we know that our a is 1 and negative 3, while our b should be 3. Therefore, for the first complex number, it should be 1 plus 3i, and then our second complex number should be negative 3 plus 3i. So this is the final answer. So it will be 1 plus 3i and negative 3 plus 3i. So that's how we solve for question A1. For question A. Okay, I hope that for this 11-minute video, this 11-minute time lapse might help you to understand this equation, to understand this, to understand this problem, hopefully, inshallah. Alright, so the next question should be B, if I'm not mistaken. Oh my gosh, so naive. Alright, the next question should be B. So, for question B, oh my gosh, wait, sorry. Okay, so an equation in a complex number system is given by z is equal to 1 divided by bracket z1 minus z2 plus 1 over conjugate z bar, where z1 is equal to 1 plus 2i and z2 is equal to 2 minus I. Okay, find the value of z in the Cartesian form a plus ib or a plus bi. Okay, so they gave us a value for two complex numbers, and then they gave us an equation, and they want us to find z. Remember, z1, z2, and z aren't the same complex numbers unless they let us know that they are the same. But since the question gave us each complex number, therefore it's not the same. Okay, so the first things first, what I love to do is I combine. Now, what do I mean combine? Before I substitute each value into the equation, I simplify this equation to become a singular fraction. Now, a over b, this is what we call singular fraction, okay? It makes things easier. So z is equal to 1 over z1 minus z2 plus 1 over z bar. Now we can combine this to become a singular fraction. We multiply, so z bar plus z1, z bar 1, sorry, forgot the 1, z1 bar, plus z1 minus z2 over z bar 1, z1 minus z2. The reason why I do this is because I don't want to make things more complicated, so I rather just simplify to become a singular fraction. So now we already combine it, then we can just substitute the values into the new equation that we have here, the one that we have simplified. So the z bar, remember, z bar is a conjugate of z1. Okay, z1 bar is a conjugate of z1. Like I told you guys before, that remember the conjugate, the real part doesn't change, but the imaginary part, the value or the direction changes from a positive to a negative, or even from a negative to a positive value. Okay, so z bar 1, which is z1 that we know for now is 1 plus 2i. For a bar, remember the imaginary part will be changed, so it will become 1 minus 2i. Then basically z1, z2, all you have to do is just substitute into the expression. So z1 should be 1 plus 2i, and then minus 2 minus I. And now for the denominator, okay, denominator we have already substituted the values. Now for the numerator, we know that our z bar should be 1 minus 2i multiplied by the first, for z1 we have 1 plus 2i minus, again, minus 2 minus I. Alright. So now, can we simplify? Yes, we can. So I'm sorry if my number 2 looks like a Z, but just to be sure, my 2 is Z. This is 2, okay? So don't get confused by how I write my 2 down. So we can simplify it by adding up the like terms. So if you want to expand it, then you may. So you will get 1 minus 2i plus 1 plus 2i minus 2 plus I. Then divided by, okay, you can simplify inside the bracket first, then you can expand it, so that it makes things easier. So 1 minus 2i, and then you expand the bracket, you will get 1 plus 2i minus 2 plus I, close bracket. Now, you can expand the numerator and the denominator. You will get, you can cancel out these terms, and you get 2. 1 plus 1 is 2. 2 minus 2 is 0. So you will be left with I for the numerator. Then divided by the denominator by 1 minus 2i, then negative 1 plus 3i. Now you'll be left with this expression. Now we need to simplify, but before we simplify, we have to expand the denominator. So I is divided by 1 expanded as usual. So negative 1 plus 3i plus 2i, and then like I said before, I squared will be negative 1. Then negative multiplied by negative 2, it will be positive. That's why I get plus 6. So right now I can solve it. I can solve the denominator, which is I divided by 5 plus 5i. And then we must simplify, we must make sure that our ratio, it will become a real number. So we will be multiplying it by its conjugate. So what will be the conjugate for the denominator, which is 5 minus 5i? Then the denominator will be 5 minus 5i. So we expand it. And like I said before, we recap for what happens if we multiply the conjugate. You will get a squared plus b squared, or even x squared plus y squared. So by expanding the numerator, you get 5i minus 5i squared divided by 5 squared plus 5 squared. And finally, we know that I squared should be negative 1, and then you can expand the negative values to become positive. So it will be 5i plus 5 over 5 squared will be 25, plus 5 squared should be 25, then add up, we will get 50. Now we want in form of a plus bi. Now we should arrange it to become a plus bi. Then f, 5 plus 5i divided by 50. Now can we separate it to become singular fraction? Yes, we can. Singular fraction for each to become 5 over 50 plus 5 over 50i. Now we can simplify this expression, since the denominator can be simplified by dividing by 5. Therefore you get 1 over 10 plus 1 over 10i. So that should be the final answer. Okay, hopefully nothing is too challenging here. If you alright, so right now we will be trying to answer B to Roman, express Z in the polar form. Now I'm sorry. Okay, so express Z in the polar form. Now polar form, we may know that the polar form should be Z is equal to R bracket cos theta plus I sine theta. Now we know that theta, it should be in radian. Okay, it's not in degrees, it's in radian. So how do we express it in polar form? Now first things first, I love to sketch out the Cartesian plane, which is the y-axis should be the imaginary number, and then the x-axis should be the real part. of the number. I don't know, we call it as imaginary real part. So this will be imaginary z, or for the complex number z. Then this will be the real part, which is for the real part of z, obviously. So how do we, firstly, we have to plot the coordinates. So originally for B1 Roman, we got z is equal to 1 over 10 plus 1 over 10i. Now this can be formed as coordinates, which is 1 over 10 is the real part, and then 1 over 10i should be the real part and real part, the imaginary part. So we plot this down. You know that 1 over 10 is the imaginary part, while the 1 over 10 are for the real part. Then we can create a triangle, a right angled triangle. Oh my gosh, this looks terrible, sorry. Triangle. And now we know that the coordinates for this will be 1 over 10, which is the vertical, oh my gosh, I'm so sorry, bracket 1 over 10, 1 over 10. So we know that for the vertical of this triangle should be 1 over 10, while the horizontal will be 1 over 10 as well. So R is just basically the hypotenuse of the triangle. This is R. Oops, capital R should be the small r. Small r. So we will be using the Pythagoras theorem to get the value for R. Now basically the Pythagoras theorem should be a squared plus b squared. So our a should be 1 over 10. 1 over 10 square, and then plus 1 over 10 square. Okay, and then if we add those two together, you will get the square root of 1 over 100 plus 1 over 100. Can we combine it? Yes, we can. Then we will get square root of 2 over 100, and then we can simplify the fraction. We'll get 1 over 50. So can we simplify it? Yes, we can. Because remember, in set form, for set A over B, okay? So it will become set A over set B. Okay, remember this is the law for set. Okay, set A over B. And then we will separate the set from A to B. Okay, so this will become the final answer on how can we separate the sets for the numerator and the denominator. Okay, I'm so sorry for the noise from the background. Okay, so set of 1 divided by set of 50. Now we know that set of 1 should become 1. Okay, remember anything that, for example, like the cube root of 1, or even 1 to the power 4, anything that relates to 1 should gives us the final value, which is 1 over set 50. So can we, oh wait a minute, it looks messy. Let me write this down. Set 1 over set 50, and we get 1 over set 50. Now the question is, can we simplify it? Yes, we can. By knowingly that 1 over set 50 comes from 25 times 2. And then remember another law in set, which is if set A times set B, we can combine it to become set A times B. Okay, this is apart from the law for set, how we play around with set expressions. Therefore, we can get 1 over set of 25 times set of 2. Now, set of 25 comes from 5, because we know that 5 squared is 25. Therefore, set of 25, or the square root of 25 should be 5, and then our answer should be 5 set 2. But wait, this is not an answer yet. We want to make it as simplified as possible to make sure that the denominator will be the real number expression. So we will be multiplying its conjugate. We will be multiplying the numerator and the denominator, the value of the set, which is set 2. Therefore, the denominator should be set 2 over 10, because we know that if set A times with set A, both terms are alike, we will get the value of A. Alright, so that's how we got it. So I hope that this part of the problem, which is to find the value of r in the simplified form, should be no problem. But if there is any problem, I could just try to repeat the process. But if you want to repeat, you can just replay this video. Alright, so the next part, okay, we know that our r should be what is the value? Set 2 over 10. Just now I showed to use set 2 over 10. So our r should be set 2 over 10. Okay, set 2 over 10. Alright, so right now all we need to find is our theta. Now, to talk about theta, to find theta for each quadrant, the first, second, third, fourth, it's going to take a really long time to explain it. But for tonight, we will be focusing on the first quadrant. Alright, so the first quadrant, there's nothing new to it. All we have to do is to find the theta. But the difficult part, if the question asks for the second, third, and fourth quadrant. But for the first quadrant, there is nothing problem or complicated about it so far. So how do we find theta? There's a lot kind of ways to find theta. You can use cosine, sine, or tangent. But for this kind of question, we already have our opposite and our sides of value. Therefore, we can use tangent. And remember, if we have a triangle, oh my gosh, sorry. If we have a triangle, a right angle triangle, if we have theta here, we can find the opposite and the side value, and you can find the degree value, theta. So the original equation to find theta, alright, some books they just straight to the point where the tan -1 and so on. But how did it happen is tan theta, we know that in maths we learn source à trois, and trois is that stands for opposite over side. Okay, tangent theta is just opposite over side. So our opposite in this triangle is 1 over 10, while our side should be 1 over 10 as well. Alright, so right now we have already established our sides for the triangle, and we have our theta. So tangent theta is equal to 1 over 10 divided by 1 over 10. Okay? And I can simplify, yes we can. So 1 over 10 divided by 1 over 10, we will get 1. So it's tangent theta is equal to 1. Now we inverse the tangent and we will get the value. Remember, I haven't changed the value to radian. So for now, we will get in degrees, which is 45 degrees. Now 45 degrees is in degrees obviously, so we have to change the radian by multiplying it by pi over 180 degrees. So pi over 180 degrees, so 45 times pi over 180 degrees, you will get pi over 4, and this will be in radian. So right now, for this question, it's pretty simple since it only happens in the first quadrant, so we don't need to worry about the negative signs, clockwise and clockwise. But that is for another lesson. But for now, let me just finish this expression in polar form. Set 2 over 10 cos, it should be cos pi over 4 plus I sine pi over 4. To be honest, there are other videos about talking about why the polar form looks like this, but for now we will be expressing it in polar form this kind of way. But if you learn more about this topic, you know that there's a rectangular form, which is in Cartesian form, in other words. But yeah, this is how we solve it. So, alright, that's all for now. Okay, thank you so much for watching. If there is any questions, you can ask in the comments. Okay, alright, Assalamualaikum.